Okay, so what we are going to do, we can approach this a couple of different ways just to kind of eliminate things and to work with stuff. So what I would do personally, my first reaction would be to take this middle equation, since it is solved out for z, and I'm going to want to plug it in to this top equation here. Because I know that when I do that, the z is going to disappear and it will leave me with a y and an x. And if I were to look at my third equation, it also has a x and a y, which means that we'll be able to use those as 2x2 systems. They'll be easier to solve whether we want to substitute them, eliminate them, or to graph them. So that is where my brain immediately takes me. So what we're going to do, we're going to take our first top equation, the y equals x plus z, although we now know that z is equal to this piece here. We know z is equal to negative 3y minus 3. And then we keep the plus 5 at the end. That will give me the chance to distribute that secret 1 that is hiding in here. I'm always going to write it in so you can see it. Distribute that secret 1 to both parts there. So we have a y equals x we haven't touched. 1 times negative 3y is a negative 3y. 1 times negative 3 is negative 3 plus 5 over on the end. I can combine any like terms that I have for right now on this side. The only like terms I have are the negative 3 and the 5. Y equals x minus 3y stays the same. Negative 3 plus 5 gives me a plus 2. And then I want to clean this up just a little bit more. I can move the 3y over to the other side. That gives me 4y over here equals x plus 2. This is where you're going to have a couple of options for how you want to do this. So I'm going to bring down, I'll bring them in blue. We have this equation here. We have the 2x minus y equals negative 4. And we have this 4y equals x plus 2. This is my new 2x2 equation. There's a couple of ways we can do this. Option 1, which I think is the option you're going to want to do, is you're going to move this x over to the other side so that you come out with minus x over here and minus x here. You'll keep your original top equation, negative 2x, positive 2x minus y equals negative 4. But we now have an equation of negative x plus 4y equals 2. This gives me a multitude of options. I'm going to zoom in down here so that you can see those new 2 equations that we have. This gives us tons of choices. We can eliminate using the x's, or we can eliminate using the y's. I'll show you both. So I'm actually going to split this page right down the middle. And over here, I'm going to write the same thing. 2x minus y equals negative 4. Negative x plus 4y equals 2. Because we've got options. Let's say we wanted to eliminate using the x's. I would take this bottom equation down here and multiply everybody by 2. That will give me the beauty of keeping this top equation, negative 2x minus y equals negative 4. But I'll now have negative 2x plus 8y equals 4. If I were to eliminate or add straight down, I'd have a 7y here. Negative 4 and 4 make 0. When I divide that by 7, y is going to equal 0. So let's highlight that to see that we know that. Or, I know you like elimination sometimes with the y's. We could do, in this case, we're going to multiply the top equation times 4, which gives me 2 times 4 is an 8x minus 4y equals negative 16. This time we're going to be getting rid of the y's, so we'll have, keeping our original equation, negative x plus 4y equals 2. If I were to add straight down over here, no, come on, there we go. My y's would cancel, a negative 4y and a positive 4y cancel out. So adding straight down, I have 7x over here. Negative 16 plus 2 is equal to negative 14. Dividing by 7 on both sides. This tells me that x is going to be equal to negative 2. I'm going to kind of tuck that information in our back pocket, because from here you have options. From here, if you chose option A and kind of did things on, let's highlight in yellow. If you chose to do things on this side and do it this way, we have y and need to find out the other two variables. So what I would do is I would take my y equals 0 and I'd plug that bad boy right back in somewhere up here. Negative 2x minus 0 equals negative 4. 2x equals negative 4. X equals negative 2. Well, that's good. That tells us what we just learned over here on the other side. So that gives me one more letter. And I can look all the way back up to the top. I have two equations that had a z in them I could use. We may as well use the middle one, the one that we already highlighted in green, this one here, because we know that y equals 0, so it's going to be very friendly to plug back in. So that's negative 3y minus 3. So that's z equals negative 3y minus 3. I can take that, plug my 0 in for y. Negative 3 times 0, my favorite, is big fat 0 minus 3. Tells me that z is going to equal negative 3. That leaves me with a set of solutions. I have an x, a y, and a z on this side. That side is done. However, let's say you took path B and you chose to work this way. We'll use the green side over here. We'll keep going in green. Should you have chosen this, I know that x is equal to negative 2, so I can plug that in. I could have done 2 times negative 2 minus y equals negative 4. 2 times negative 2 is negative 4 minus y equals negative 4. I want to move the 4 to the other side by doing the inverse, by adding. We go that negative y equals 0, which means that positive y equals 0. That's good. We can keep kind of comparing to the other side. We're seeing that things are coming out the same way, which we like. And I'm just going to kind of move this all up just a tiny bit so we have a little tiny more room. And then move this up just a tiny bit so that I can fit, there we go. I can fit my z in there. So the very last thing, same exact situation we were in last time. You have x and y. We had x and y here. We're going to plug right into that z one more time. Z equals negative 3 times y minus 3, which means z equals 0 minus 3 is negative 3. So there are two ways to have approached this once you substituted that first part. So pro tip number 1 is to use, like we did here, use this middle equation as your plug-in equation up into the top. That eliminates the need for a letter z and moves us on quite nicely, if you ask me, to give us to where we were at, where you could use elimination in two different ways. You could have eliminated, like we did, eliminating the x's or eliminating the y's down at the bottom to get either of these two answers. So no matter what you do, I'll put it in black to make it definite. Your solution for this, you can either say x equals negative 2, y equals 0, z equals negative 3, or we can continue to write it like this in parentheses in order of the alphabet. I will shrink that down so you can pause and look at it, and there you go.